Now question is, test whether the function f of x, which is 2x minus 3 raised to 3 by 2, is differentiable at x is equal to 3 by 2. So we don't want here exactly derivative, we have to check whether this derivative of function exists or not. Okay, so test whether function is differentiable at 3 by 2 or not. So when we can say that function is differentiable at say some x is equal to a, how we find the derivative of function? We know first principle method. So using first principle method, f dash of a is what? Limit h tends to 0, f of a plus h minus f of a upon h. So for given function f of x, first find out f of a, one term, then from f of x find out f of a plus h, where h is small increment in x, and then subtract these two, f of a plus h minus find f of a, divide by h, and then find limit of this, limit of what? H tends to 0. If this limit exists, that is what? F dash of a, that is d by dx of fx at x is equal to a. So if this limit in case does not exist, then we can say it is not differentiable at x is equal to a. Okay, so let us check here whether this function is differentiable at x is equal to 3 by 2 or not. That means our a is what? 3 by 2. So here given function is f of x is 2x minus 3 raised to 3 by 2. Now we want at x is equal to 3 by 2, that means a is 3 by 2. So let us find f of 3 by 2, that is find out f of a, f of 3 by 2. So put x is equal to 3 by 2 here and here. So 2 into 3 by 2 minus 3 whole raised to 3 by 2. Now these 2 and 2 cancel. So 3 minus 3 is remaining, right? 3 minus 3 whole raised to 3 by 2. Now 3 minus 3 is 0. 0 raised to 3 by 2 is what? 0. Because 0 raised to any number is what? 0. So that means f of a, that is f of 3 by 2 is 0. So this one part is over. Now let us find f of a plus h. That means here, how we can find a plus h? That is a is 3 by 2 plus h. F of a plus h. If you want, you can write here f of a and here f of a plus h, that is 3 by 2 plus h. So here now this is f of x, we want f of 3 by 2 plus h. That means put here x is equal to 3 by 2 plus h. So f of 3 by 2 plus h is equal to 2 into, put x is equal to this 3 by 2 plus h. 3 by 2 plus h minus 3 and this whole raised to, so write another bracket, whole raised to 3 by 2. Okay, simplify this now. So 2 into 3 by 2, then plus 2 into h, 2h minus 3 whole raised to 3 by 2. So 2 to cut, 3 plus 2h minus 3 whole raised to 3 by 2. So this 3 cancel. So this is 2h raised to 3 by 2. Now ab whole square, we know we can write a square into b square. So 2h whole raised to 3 by 2, we can write 2 raised to 3 by 2 and h raised to 3 by 2. So we can find 2 raised to 3 by 2 again if you want now. Or write same now. So this is 2 raised to 3 by 2 into h raised to 3 by 2. So by this first principle method. If you want, write this again here. Now a is what? 3 by 2. So therefore f dash of a, that is 3 by 2, is equal to limit h tends to 0 f of a plus h. A is 3 by 2 plus h minus f of a. A is 3 by 2 upon h. Now we know values of this. So limit h tends to 0, f of 3 by 2 plus h. F of 3 by 2 plus h is what? 2 into 3 by 2 into h raised to 3 by 2 minus f of 3 by 2. F of 3 by 2 is what? 0. So right here 0 upon this h. So minus 0 is there. So now don't write that. So answer is 2 raised to 3 by 2 limit h tends to 0, 2 raised to 3 by 2 into h raised to 3 by 2 upon this h. You can write upon h here, or you can write simply upon h here. Now this is constant, so we can write outside the limit. This is given in terms of hh. So h means h raised to 1. Now we know that a raised to m upon a raised to n is a raised to m minus n. So first write this 2 raised to 3 by 2 limit h tends to 0 h raised to 3 by 2 minus 1. Okay, basis same h, a raised to m upon a raised to n is equal to a raised to m minus n, that is here 3 by 2 minus 1. Now what is 3 by 2 minus 1? So 2 raised to 3 by 2 limit h tends to 0, 3 by 2 minus 1 cross multiplication, 3 minus 2 1, 1 upon 2. So now there is no upon h. H raised to 1 by 2 upon 1 is there. So we can write h equal to 0 directly. We don't want upon 0. In numerator we can write 0. So here 2 raised to 3 by 2 into, put h is equal to 0. 0 raised to half. 0 raised to any number is what? 0. So 2 raised to 3 by 2 into 0. So answer is 0. So we can simplify 2 raised to 3 by 2, but as this is 2 raised to 3 by 2 into 0, so our answer is 0. And that means this f dash of 3 by 2, this limit exists, and that answer is what? 0. If it is does not exist, our answer is does not exist, then we can say that this function is not differentiable because limit does not exist. Does not exist means non-zero upon 0, right? Or like 0 upon 0 we can simplify. So if upon 0 is there, then we say limit does not exist. But here our answer is 0, and that means f dash of 3 by 2, this derivative exists, and that our answer is 0. So we are right. Therefore function is differentiable at x is equal to 3 by 2. Therefore fx is differentiable at x is equal to 3 by 2.